Hi, welcome to the fifth trigonometric tutorial titled The General Solution. In today's tutorial, we will be looking at what the general solution is and why we have such a section. In terms of what you need to know, you need to be familiar with your grade 10 work on trigonometry. You also need to have gone through the first 4 trigonometric tutorials. I want you to think about the following. If I said sine of x is equal to 0,5, what is x equal to? You'd very easily be able to tell me x is equal to 30 degrees, right? Almost. 30 degrees is one of an infinite amount of possible answers that you could have given me. Think about this. Sine of 150 degrees is equal to 0,5. Sine of 390 degrees is equal to 0,5. What about sine of negative 210 degrees equal to 0,5? The different possible answers are endless. Hence we have developed a thing called the general solution. Let us go through that. We are now going to have a look at general solution. General solution, now you'll notice here that I've drawn the trigonometric graph sine of x. This is the graph f of x is equal to sine of x. Right? And we are going to look at what x values we can have when f of x is equal to a half, or rather when sine of x is equal to a half. Now special angles will tell us very simply that in order for sine of x to equal a half, x will have to equal 30 degrees. Correct? Well, almost there. Let's write this over here. X, we know that if sine of x is equal to 0.5, second function sine of 0.5 is going to give us 30 degrees. Is that correct? Like I say, almost there. There's only one slight problem with that. Let's look at when sine of x is equal to a half. That's going to be somewhere over there, right? Now let's draw a line across there. The different x values are going to tell us where sine of x. Now this is the graph sine of x. Hence, wherever sine of x touches this blue line that I've drawn is where sine of x is equal to a half. Notice something. There's a lot more solutions than just 30 degrees. There's 30 degrees. There's over here which is going to be 390 degrees. There's over here and over here which I'm not yet taking into account. In fact, I will. This one is going to be 150 degrees. This one here is going to be 510 degrees. This here, by the way, is 30. This point here is equal to negative 210 degrees. This point of here over there is equal to negative 330 degrees. So I've got a number of different values, and notice that my sine graph is going to just continue in this pattern to positive infinity and to negative infinity. So when sine of x is equal to a half, there's a lot of different angles that x could be. But let's look at this. What's the relationship between 30 and 390? Isn't there a difference of 360 degrees? Because the graph, the sine graph, repeats itself every 360 degrees. So to get to 390, I could say plus 360 degrees. But I could also go negative. I could also go negative 360 to give me negative 330. So I'm going to say that x is equal to 30 degrees plus k times 360, where k is an element of integers. That means that k could be positive 1, k could be 0, that will give us 30 degrees, k could be positive 1, that would give us 390 degrees, k could be negative 1, that would give us negative 330, and k could have any other integer value. But that only accounts for those values. What about those other three values? Now remember, when we sketched our 30-degree angle on the Cartesian plane, we sketched it either there, but it could have also been over there for sine of x to be positive a half. That angle is in the second quadrant, which means that x will equal 180 degrees minus 30, which is the same as 150 degrees, which would account for that one, plus 360 minus 360, so it's 150 degrees plus k times 360 degrees, again where k is an element of integers. That there is the general solution. So when sine of x is equal to positive 0.5, x could either equal 30 degrees plus k times 360 or 150 degrees plus k times 360. And that's because the sine graph repeats itself, or rather the sine function repeats itself every 360 degrees. The general solutions for sine and cos are both plus k times 360. So for cos of x, if cos of x is equal to something, it means that x is either equal to, let's say cos of x is equal to root 2 over 2. We know from special angles that this means x is equal to 45 degrees, but it's going to be 45 degrees plus k times 360, because the cos graph also repeats itself at intervals of 360 degrees, where k is an element of integers, or x is equal to, now where else is cos positive? In the fourth quadrant. So it's 360 degrees minus 45 degrees plus k times 360, again where k is an element of integers.